Hi everybody, Mrs. Pesic here. We're looking at section 4.1, which is radian and degree measure. And remember, this is the start of the trigonometry chapter. And you've already done quite a bit of this section in the Blended Learning Day assignment. So you already had introduction to what standard position is for an angle, what coterminal angles are, how to measure an angle in both radians and degrees. We also looked at what the circumference is of a circle and what 2 pi is and so forth. We also talked about whether an angle, if an angle measures, 5 pi over 4, what quadrant would that be in? And we talked about coterminal angles have the same initial side and the same terminal side. We talked about complementary angles and supplementary angles. So if you don't remember any of this information, please refer back to those videos from the Blended Learning Day assignment. We also talked about how to convert from radians to degrees and from degrees to radians on those videos. And I think that where we kind of left off was maybe right here. So let's pick it up from right here. Angles can be measured in finer units than degrees. So for example, 48 degrees, 15 minutes, 24 seconds is how we would read this. Of course, you know what the degree symbol looks like, but 1 tick would be for a degree, a measurement called minutes, and 2 tick marks would be for a degree called a measurement called seconds. And there are 60 minutes in 1 degree when we're talking about measuring angles, and there are 60 seconds in 1 minute. All right, just like when we're talking about time. All right, so if we wanted to convert decimal degrees to degrees, minutes, seconds, or vice versa, you can use your calculator to do that. So when we do this, let's pull up our calculator, and this was 48, 15, 24. I'm going to try and remember that here. So if we go to a calculator page, and we want to do 48 degrees, so we go 48 and we enter the degree symbol. The degree symbol, you got to push this question mark button down here, and then you can pop in the degree symbol. 48 degrees, it was 15 minutes, so we're going to do 15. And then again, we push that question mark button and we push that little minute symbol. And then this was 24 seconds. So we go 24, but this time, I mean, you might think you push this one, but you don't. You actually have to push the minute one twice. So question mark, minute, question mark, minute. That's how we're going to get seconds. All right, so now that we have that, we want to go to this book option right here. See this book button? That is like your menu of all sorts of different options, and we want to push letter D, so it gets us down to the D options. And then if we arrow down here, we want this in decimal degrees. That's DD. So I push enter on that, DD. And we're saying, oh, you want to convert this degrees, minutes, seconds to decimal degrees? And I say, yes, I do. And it converts it to 48 degrees, 48.2567 degrees. So we've converted from degrees, minutes, seconds to decimal degrees. Let's see how this would work in reverse. So if I enter something like 25.683, and I want to say that's degrees, so it's a decimal. Did I say 25? I thought I did. 25.683. Let's push our degree symbol. So that's degrees right here. And now I want to convert that to degrees, minutes, seconds from decimal degrees. So again, I'm going to push the book button, and this time I'm going to go down to BMS. Whoops, there it is. So I pushed degree, minutes, seconds. It's saying, oh, do you want to convert that decimal degree to degree, minutes, seconds? Why, yes, I do. And so it does convert it. It's 25 degrees, 40 minutes, and then 58.8 seconds. All right, so that's how we convert very easily and quickly with our calculator. All right, so we've done that. So recall, radian measure, theta equals S divided by R, so that's arc length divided by radius. So theta is your angle, and this one means it has to be in radians, not degrees. So your angle measured in radians is going to be equal to the arc length, some portion of a circle, think of it that way, divided by the radius. All right, so for example, if I want to know the relationship between, let's say, this angle theta here and this radius here and the arc length, which we refer to the arc length here as S. That's the relationship. Theta is equal to S over R, or you could write it as S equals R times theta if you multiplied both sides of that equation by the radius. So let's take a look at an example here. Let's find the radian measure. So if we're trying to find theta here in this example, that's our radian measure. Theta is equal to S divided by R. So that's the arc length divided by the radius. So that's the arc length is from here to here. This is what we mean by the arc length. It's 12 centimeters. And so we take 12 divided by 6 and we end up with 2. So that theta measure is going to be 2 radians. All right. Let's take a look at another example. Find the arc length here. Well, the arc length here is going to be S, and our formula could be S equals R times theta. Again, that comes from theta equals S over R. And so if we're trying to find the arc length, I can plug in the radius of 4, and the theta, well, I know that that theta is 180 degrees, right? From here all the way around here is 180 degrees, but we also know that that's pi radians, and we have to use radians for this formula. All right, must be in radians, okay? And so we would get that the arc length is 4 pi radians. All right, so arc length for a circle with radius r, a central angle theta, intercepts an arc of length s, given by s equals r theta. We've just been using this formula where theta is measured in radians. Let's take a look at one more example. A circle has a radius of 27 inches. Find the length of the arc intercepted, I think I'm missing a letter in here, intercepted by a central angle of 160 degrees. All right, so here's our picture, and we're trying to find the length of the arc. So I want to know, what is this arc that's been intercepted by this 160 degree angle? So arc length formula is S equals R times theta. So we're going to use that formula, but we must convert to radians first. Formula does not work with degrees, so we have to convert. And as you know from our work on the Blended Learning Day assignment, you can take 160 degrees and multiply by pi radians over 180 degrees to get this to convert. And we can say 20 goes into 168 times, 20 goes into 180 9 times, so I end up with 8 pi over 9. So that's what I will plug in for the angle theta, 8 pi over 9 radians times our radius of 27. So that's going to be our arc length here, and I can actually divide this 9 out with 27. 9 goes into 9 once and 27 3 times. So I end up with 24 pi, and the units here would always match the units for the radius. So the units on the radius was inches, so the units for the arc length here would also be in inches. So 24 pi inches for this. All right, I'm gonna stop this now, and then you'll need to start watching the second video.